Hello ATS 315 students, Dr. Shragi here, and I'm here to just sort of do a little presentation associated with that first short reading in the Neil Stephenson book about the different kinds of operating systems that you could have chosen when you are doing your work in computer science, but we have in fact chosen one in particular. We're going to be working with Linux. Now, in some printings of this book, this chapter is actually called At the Crossroads. And of course, he's talking metaphorically about a crossroads, like a place where you could make a decision and go different ways. In our case, what he's specifically talking about is, any given discipline or any given person or whatever could have chosen different kinds of computers, could have chosen different kinds of operating systems. Maybe you're a Mac person, maybe you're a Windows person, maybe you're something, I don't want to say more interesting, but you know what I'm saying, maybe you're really into Google OS, Chrome OS or something like that. There are a number of different alternatives that any, person could have chosen, or any group like a company or a discipline like atmospheric sciences. As it happens in atmospheric sciences, most of the programming work gets done on Linux computers in contrast to Macs or PCs, as we'll see. But Stephenson pictures this more literally as like an intersection or a crossroads. And he says, while you're at this crossroads, you could choose a number of different things. One thing you could choose would be to go the Microsoft direction. If we just focus on more recent years with Microsoft, you could be talking about Windows 7, Windows 8, 8.1, and now Windows 10. And of course, the criticism of of Windows among people who are not Windows people is, fairly well known, if kind of trivial. I mean, they'll say that Windows is ugly, for example, and they'll point to, to use the metaphor of these this intersection, these are the ugly cars. Man, Microsoft produces billions and billions of these things. There are literally several billion computers out there right now running Windows, but they're all pretty ugly. I mean, forgetting the computer itself, and physically, whether that HP notebook is as beautiful as your MacBook Air, which it's not, but just how Windows itself looks when you take it out for a spin, shall we say, tends to be pretty ugly, and it isn't, how should I put it, it started a lot worse. I mean, if we go back through the history of Windows, if you look back at Windows 3.1, which came out in like 1991 or so, oh my goodness, those shocking colors, the terrible fonts, the bad design, you would never make an application that looks like, the screen from Windows 3.1 today. And frankly, it got more familiar, but still fairly ugly when they switched to Windows 95 in fall of 1995, where, I mean, at least there's some familiar aspects of the interface here, like the start button and so on. But I mean, these applications are absolutely ugly. Poor choices of color, poor choices of fonts. That just wasn't Microsoft's thing in 1995. They weren't thinking in terms of what colors things would be. They were just thinking in terms of getting a billion copies of Windows 95 out to people. There were a couple of releases after Windows 95, Windows 98, Windows Me, of all horrible things. Windows Millennium Edition is what it stood for. But the next one that most people were familiar with was Windows XP, which came out in 2001, and I actually still have computers that run Windows XP. Again, it's starting to look a little more modern, rounded corners. Well, modern maybe is not the right choice of words, because that style is sort of going out of fashion. But I mean, it's starting to look like something we at least hate. You know what I'm saying? Better choices of fonts, better designs, better choices of color, better layout of applications, etc. Then there's the universally hated Windows Vista, which came out, about 2005. Again, some of the things that we're starting to expect in an operating system, like search buttons everywhere, start showing up. Like if you look over there near the start button, there's a little place where you can search for applications. Geez, I only use that like 100 times a day, and I didn't even know that started at Windows Vista. You can see like there's desktop widgets and gadgets and so on that will later become things like tiles in later versions of Windows. I mean, even though Windows Vista was not such a great technology, it actually had lots of really good ideas there. But, at least at the time I'm recording this, what people really know and love about Windows was Windows 7. Windows 7 was certainly a return to a very business-like appearance in Windows. There's not a lot of toys to it. It's just a very clean interface, the so-called arrow interfaces, to use Microsoft's terminology. Some layers of transparency to it, nicely designed icons, a start button, an accessories tray down there, a system tray, I believe is the right word in the bottom right. I mean, this is really getting to be not just, you can pin applications to the start bar, things like that, the kind of things you expect in a modern operating system. And then they went, of course, all future on us with Windows 8. Windows 8 with all of its crazy tiles and all that kind of stuff, it's beautiful, it's interesting. I have to admit I never owned a Windows 8 computer, so I don't actually know exactly how groovy this was, except like on a tablet or something, which really seems like what that was more designed for. With Windows 8.1, they started putting back things like start bars and stuff like that, but the writing was on the wall that this was not what business wanted to use, or colleges wanted to use. And so with the release of Windows 10, it's getting back to an interface that looks more like what kind of is seen as a more classic Windows interface, with a start button and a system tray, with these live tiles as part of what you see when you see the start button. It's a very clean interface, and history will decide whether it was a good idea or a bad idea. I don't know that I would look at that screen and say that that's ugly. I mean, I think the criticism that Windows is ugly that is neither important nor necessarily even relevant. Now, across the street from Windows, to use the metaphor from Stephenson's book, is Apple. Now, Stephenson wrote this book in about 1998, and that was an interesting time in the history of Apple, because for all intents and purposes, they were out of business. It's hard for somebody your age to know just how bad Apple had gotten. Apple's computers at that time were costing about $3,000 to $4,000. In 1998 dollars. I mean, you could buy a car for under 10. I mean, they were just too expensive. They had weird design choices in terms of like how you had to actually set yourself how much memory you were willing to let each application use and things like that. I mean, it was just a difficult thing to use. Mac was almost out of business. And you know, when you look at something like Mac OS 2, which came out, I don't know, sometime in the 80s, I mean, that's horrifying. I mean, it was a badly thought out operating system. Somebody at Apple started it, and they wrote it, and, you know, a whole team of system administrators created all of this, and, you know, you can move forward to, like, Mac OS 3, and, I mean, I can only imagine how much Steve Jobs is rolling in his grave right now that we're even looking at something so ugly. You know, it was badly thought out, but, you know, you don't have to go into the paleo history of Mac OS to see these things. I mean, Mac OS 7.5, I had a Mac OS 7.5 computer in the, I don't know, mid to late 90s. I can assure you that is not what Windows computers looked like at that time. Mac was way behind the curve. But of course, somewhere along the way, Steve Jobs came back to Apple and brought with him Mac OS 10, which is really a type of Unix, but we'll get there at a later time, and you can see why Mac people got very excited again. I mean, if you compare this Mac OS 10.1 slide to the Mac OS 7.5 slide I just showed you, I mean, how is this even the same company? Well, in many ways it wasn't. For all intents and purposes, they went out of business. But clearly this is a much more modern looking operating system, and of course if you move through all the different releases of Mac OS 10 that have come since, they're up to, at the present time of recording this, a Mac OS 10.11, El Capitan. And, I mean, it's lovely, and I have no doubt that there'll be things about the current operating system's interface that people love and things that they hate, but there's no doubt about it, Apple is back, right? I mean, they've been back for like 10 years now, right? They make big, beautiful, powerful computers at prices people can afford, unlike the business model, you know, 15 years ago or whatever. And so the metaphor that people tend to use for Mac nowadays is that they kind of make BMW computers, right? They're not priced necessarily for everybody, but they are glorious, and they are well-machined, and they are perfect, right? You can spend a whole lot less for a Windows computer. You can go down to Staples and buy a Windows computer for, you know, a Windows desktop for $200. You can buy a laptop probably for that if you really want to do it. Well, you're going to spend more money than that on a Mac. On the other hand, it's going to be fine Apple engineering. It's going to be a beautiful piece of equipment. Now, your textbook then, your book in the beginning, mentions another operating system, BOS. BOS went out of business. Let's not worry about them at all. Time has passed. But then you get to the interesting possibility. Microsoft was a company. You and I can picture what the busy people at Microsoft do all day. Apple is a company. You and I can picture what the busy people at Apple do all day. Unix/Linux, we'll get to what the difference is another operating system, but it isn't a company. It's just folks. And I love the analogy that the book uses where, you know, think of this as like a camp, okay, where there is a company selling BMWs across the road. They're just sort of a camp, a bunch of people doing stuff, because that's what happens with Unix. A lot of what happens with Unix and Linux, we'll learn about all the details in just a little bit, is just done by people. They're just guys and women who like to write computer programs, and they download the source code of some piece of Unix and they say, I can make this better, and they write it and it gets better, or they can make this more secure, or they can make this run faster. And it's just a continuously evolving set of everybody sort of hacks it together. And, you know, it's kind of like an extemporaneous community. You know, no one's organizing. There's no head of Unix, there's no head of Linux. It's a weird mixture of companies and individuals and people with too much time on their hands and all working together. And what they are building is very, very different than what Windows is building. Microsoft builds with Windows and what Apple builds with OS X, because what Linux is building is effectively a tank. Okay, I don't mean tank like a big lumbering piece of equipment. We're talking modern tanks that can fly across the desert floor at 45 miles an hour while driving over a village. Okay, that's a horrible thing, but you know what I'm saying, right? These are modern, high-tech, powerful, fast machines that crush everything that's in their way. Okay, this semester you are going to be using a Linux computer. It happens to be a computer I own called Chesapeake, and Chesapeake, most Linux computers have names. And Chesapeake is actually, we're in my office right now, and it's right there underneath my desk. At some point I'll probably crawl under the desk on one of these lectures and show it to you. But it's just a PC. We bought it for like $499. We took Windows 7 off of it and put a version of Linux on it called Ubuntu. And it's a beast, okay? We'll learn more over the course of the semester of why a Linux computer is more powerful than like a Mac or a PC, but you're going to find out, gee, if we're going to be doing things like running models or making weather visualizations, you know, with all kinds of fancy graphics and stuff, it's going to have to be on something like a Linux computer. You know what? You probably own a Unix computer right now. You may not know it, but like, for example, Android phones, Android is a type of Linux. If you own like an iPhone, iOS is a type of Unix, which is related to Unix, we'll see in just a little bit. In many ways, Linux and Unix took over the world. It's just they did it kind of invisibly. We'll see. So yeah, just real quick here, just to make sure you're clear, this is separate from the issues of these mobile operating systems like iOS on your iPhone or your iPad or whatever, or your Apple Watch or whatever, or Android, which could be running on your smartwatch or your smartphone or whatever. You know, Android TV, God forbid, or whatever. Okay, but those are types of Unix computers too. And we're going to be interested over the course of the semester is why can they do the things they do, what does it take, etc. How did we get to this place? I mean, wow, we've had a long history of computers. You know, the computers have been a part of everybody's day-to-day life since about 1980, 1982, something like that. How did we get there? Well, Microsoft took one kind of path. Very early on, Bill Gates and his other software engineers developed MS-DOS. And it was a crude command line type thing, very similar to what we're going to be doing with Linux, but we'll get there. But it was, and then with time they developed Windows. Windows was originally little more than a menu system. Windows was basically just the way you launched different DOS applications. It was a pretty way to launch DOS applications. In fact, Windows wasn't the only such alternative back in like the late 80s, early 90s. There were other pieces of software like that you could install on your computer that gave you ways to launch DOS applications using your mouse and stuff like that. But Windows was the one that won, okay? Unsurprisingly, since it was the one made by Microsoft, the people who made DOS. But there were other alternatives. You might have heard of OS2, you might have heard of PC-DOS. There are other examples of these kinds of, it looks like Windows, but it's not. It's really just sort of a menu that is picking DOS programs for you. But then, gradually over the course of several years, the DOS parts of Windows disappeared, and nowadays, of course, I mean, certainly for the last 15 years, Windows really has no tie to DOS anymore. There's no way to run Windows in like a command line anymore meaningfully. There are some hacks you can do and things like that. But by and large, if you're at a Windows computer, you're not typing commands in at a blinking prompt. You are working with the interface. You are clicking on things or touching things or swiping things or whatever, scrolling, all that kinds of good stuff. It is a, for lack of a better word, modern type of interface. The bottom line here is, though, Windows followed its own path. It started, one fine day, Bill Gates started writing DOS, and here we are now with Windows 10, 20 some odd years later. Oh God, 30 years later? Something like that. More than that, probably, oh my. Okay. all along the way, it was a trade secret. Okay, you can't go onto your PC and look for the C programs that are Windows. You don't have access to them. They're not on there. They are trade secrets. They are all owned by Microsoft. Apple started off very much the same way. Early on in the history of Apple, the programmers that Steve Jobs and Wozniak and so on had were actually writing from scratch their own operating system. Forgetting the early histories of Apple, like Apple II and things like that. The early versions of Mac OS, they started from scratch. But they started from scratch with the idea that there shouldn't be any kind of command line. You should never just be sitting there typing in commands the way we're going to have to do it on Linux, but that's another story. They wanted it right from the start to be you click, you drag, you scroll, that kind of stuff. And they built it that way right from the start, which is kind of impressive, but they never got the business model down. Apple never could compete on price, never could compete on features, and just gradually bled off to basically zero market share by the mid-90s. And they were a cash-rich enough company that they could survive for a while, but basically by the mid to late 90s they were out of business. They never quite completely went out of business, but you might know that Steve Jobs, he was actually thrown out of the company, and then at some point he came back. And when he came back, he brought a new operating system, which is known as Mac OS X, which is basically what Macs run today, which is a version of Unix. We'll talk about that in just a little bit. He brought that back to it, made Mac OS look beautiful, made it run faster, more reliably, more securely. It was easier to find programmers who already knew about Unix who could then write applications for it, in contrast to having to teach them from square one how Apple does things. This was a new thing. So the bottom line, Apple had to give up on its old Mac OS about 1998, something like that, I can't remember the exact year, and brought Steve Jobs back with his, he was at a different company and he brought Mac OS X with him back, which is basically a type of Unix. And in fact, if you know where to look, a lot of that Unix code is still there. We'll actually be poking around on a Mac at some point this semester, and you'll be able to see you can actually find recognizable C programs or Fortran programs or C++ programs and so on that are part of, that is how your Mac works, and you could in theory make changes to them. Now in practice, Apple locks all those files down. You don't have permission to actually change any of them, but they're actually there on your Mac. Little cookie crumbs to see this is really Linux, or Unix strictly speaking, but we'll get there. Let's be clear about this business of Unix. No company owns Unix. Unix was invented by a consortium of colleges and corporations a long time ago, like early 70s. In some ways it was sort of owned by AT&T at first, in some ways it was sort of owned by HP at first, but basically all that's long since been resolved. It basically isn't owned by anybody. An analogy I like to use here is think of Unix as being, okay, let's say you broke the pitcher on your blender. You got a blender, you were making smoothies, and you broke the pitcher. The only pitcher that's going to fit on your blender is going to be whatever brand of pitcher you've got. If you've got an Oster blender, you're going to have to go buy the Oster blender pitcher. That's kind of like Microsoft, okay? The only things, it's a product, it's a whatever. You have to have exactly the right thing. Think of Unix as more like a set of standards, like the description of how far apart and how heavy and so on railroad tracks should be. Okay, then anybody who wants to build their own railroad cars can do it. There's not like there's a Railroad Incorporated that's where you have to get your railroad cars from. No, as long as you follow the rules and they're this far apart and they can support this much weight and they connect using this kind of connector to the car in front of them, it does not matter a damn bit who built the railroad car. That's more what Unix is like. As long as it works together with this and it runs this way and you can change how you work, as long as the result is that it does it this way, you can make it run faster or more secure or whatever, it's still Unix. Okay, Unix was designed to run on lots and lots and lots of different kinds of computers. If it's got a computer chip in it, somebody can figure out how to make Unix run on it. Anything from a watch, to a calculator, to a smoke detector, to a thermostat, to whatever. If it's got computer chips in it, it probably can run Unix. Unix is weird in that way. Microsoft Windows runs on computer chips made by either Intel or AMD. Apple makes their own chips these days. And you can't run Mac OS on some other kind of chip. You can't run Mac OS on a Nest thermometer. Okay? There's only certain kinds of chips it's designed to work on. Unix, with enough tweaking, you can get it on any damn thing. Okay? It is vastly more powerful than Windows or Mac. Lots of features that you think your computer should be able to do are disabled on your PC or your Mac to keep you from getting into trouble. Not necessarily legal trouble, but like as in causing harm to your computer. Oh my goodness, that is not the case on Linux. You'll be astonished over the course of the semester what we can get away with on a Linux computer, of things we can make a Linux computer do. There are many, many different versions of Linux. Of Unix, rather. You go out there and basically, like for example, any company that sells servers, like Sun, they sell servers to corporations and so on. They probably make their own version of Unix that runs specifically on their chips. So like Sunday, they actually do have one. They call it Solaris. That is what runs on Sun computers. And the same is true of IBM. The same is true, IBM's version of Unix is called AIX. HP, I can't think, HPUX is the name of the version of Linux thing. Anyway, lots of different companies manufacture and sell computers, and they put Linux on it, or Unix on it, with their own slightly different version on them. And some of them also are designed to work on specialized pieces of equipment. I mean, if you have a sensor that attaches to somebody's car to read the little computer chip that's in the car, that's probably a Unix computer that's doing that, because Unix is very easy to adapt to make it work with like something that's on a port, like a sensor or a peripheral of some kind. Some of them are just designed to do certain kinds of calculations very fast. Silicon Graphics is a company that makes computers that are designed to do to produce 3D graphics for like companies like Pixar very, very quickly. Produces 3D graphics at a much higher resolution, much faster, more complicated algorithms, because they wrote a version of Unix that is optimized to do that. It can do other things more slowly because it's spending more efficiently its time on other things. There are literally several dozen versions of Unix out there, but one is most important, and that is Linux. Linux was created by a programmer called, he was Dutch, I believe. His name is Linus Torvalds. Linus Torvalds wrote Linux, and he had a really good idea. He said, let's make one really good version of Unix that is for PCs. Because here's the deal. If you go to Sun and you buy a Sun server from that company and you put Solaris on there, they're going to charge you a couple $1,000 just for the computer itself, because they don't manufacture very many of them. I mean, Sun might only sell a few thousand computers each year. They're big, expensive computers because they don't produce them in bulk. Meanwhile, Taiwan is cranking out 1 billion Intel computers a year. Linus Torvalds' brilliant idea was, let's make a really good version of Unix that runs on that, because that's cheap. Right? I mean, you can buy the stuff to build a Windows computer for probably $40–50 with the parts. Okay? These are cheap. I mean, Chesapeake, right there below my desk. We paid like $499 for it, okay? $499 won't buy you the cables for an IBM power server, or whatever they call them these days, okay? Because this is just manufactured in bulk. Okay, so Linus Torvalds' really good idea was make a version of Linux that's really good and runs on PCs because they're cheap and will take over the world. And it actually is very popular, especially outside the United States. If you go overseas, a large chunk of the machines just out and about will be running. I mean, if you go to the coffee shop and look, yes, there'll be people running Macs, there'll be people running Windows, but there will be people running things like Linux on their computers. Workplaces, a lot of workplaces, they're using a Linux computer as just an alternative. They're cheaper, they're easier to maintain, etc. Almost all web servers out there run Linux. All numerical weather prediction models like GFS and so on, and WRF and so on, are all running on Linux computers as well. Chesapeake, which we'll be using this semester, I'm pointing to it right there. Chesapeake runs a version of Linux that's called Ubuntu. Ubuntu happens to be a particularly human-friendly version of Linux. It's relatively easy for me to do the tasks that can be kind of complicated, like setting up new user accounts I mean, a Linux computer lets you have literally, I think their limit is like 10 million accounts on the computer. Couldn't really actually have 10 million people all logged in at once, but we could have literally large numbers of people logged into the computer at once. Try that sometime on your Mac or on your PC, right? I mean, it just doesn't work. So anyway, Ubuntu has the features set up in a more human way. It's easier for me to manage your accounts. So I chose Ubuntu as the version of Linux that I put on there. Another common version of Linux that you might be familiar with is Google Chrome OS. You might have seen Chromebooks. Maybe you know somebody in the dorms or something who has a Chromebook. Those little cheap notebooks that run Google Chrome OS, that's actually just a version of Linux where they've disabled a lot of the really powerful features. You know, you can't set up an e-commerce hosting site and take people's credit cards on a Chrome OS computer. They've disabled those kinds of features so that you don't do something bad. But in general, I mean, Google Chrome OS is a Linux type of computer. And then there's the whole weird world of like the mobile computers. I mean, hey, I'm holding an Android computer right here, right? It's my phone. I've actually got PowerPoint running on it. That's where I'm looking at my slides right now. Android is a version of Linux. I mean, this is a computer. There's a very small, cheap, I don't remember if this is a Snapdragon chip in here or what, but it is this small, low price, low power chips. Low power as in they're not drawing much energy. Chips that run in smartphones. Android is a special version of Linux that is designed to work on these kind of processors. More importantly, from your point of view, they're also designed to be optimal for like the... it's a version of Linux where the chip spends most of its time working on like the interface. Like for example, keeping the scrolling really smooth. There's nothing worse than when your phone gets kind of jittery when you like scroll and it moves and jumps, or the fonts render kind of badly and it's kind of hard to read or something like that. Right? Android is designed to be, it's spending most of its CPU cycles working on that, keeping it scrolling smooth, it's rendering a graphic smooth, it's rendering a font smooth, etc. Same is true of iOS, okay? If you have an iPhone or an iPad or something like that. iOS is a version of Mac OS 10, which itself was a version of Unix. And it is, so, I mean, you've got an iPhone, you've got a Unix computer in your pocket, okay? But again, it's mainly designed to be doing the heavy lifting of like controlling how it scrolls, controlling how the little animations, making the animations smooth. It's using most of its power. It's a version optimized to do that. Would it be possible to put another type of Linux on this little computer? Yeah, that's what hackers do. They find all kinds of ways to do weird things. I mean, they could probably get in there and figure out how to take that Snapdragon processor and run a different version of Linux on there, or something like that. But it wouldn't necessarily be as smooth as Android is. Android was made for this. So, just to kind of summarize how this works here, Windows is its own thing. Windows started from scratch with DOS, and they've just sort of gradually evolved from there. But it's always been a trade secret inside of Microsoft. You can't get access to the codes or anything like that. Unix is related to everything else. Unix came from the world of corporations and collaborations with universities and so on, and has become something sort of crowdsourced. Anybody who wants to try to make Unix better can download parts of it, try to fix it, try to make it more secure, whatever. And if it improves it, great, and you can do whatever you want. Apple took a copy of Unix way back in like '98, before Steve Jobs did, before he came back to Apple, and made Mac OS 10 out of it. Okay, but Mac OS 10 is in many ways just a type of Unix. Okay, he took it and he made it more Apple-looking, but he took it and he made it that way. Later, Apple themselves took Mac OS 10 and they made changes to it to optimize it more for little screens and so on, and called it iOS. Meanwhile, hackers and the world took Unix and made Linux out of it, with the guidance of guys like Linus Torvalds, who they took Unix and they made a special, really strong, really easy to use version of it and called it Linux, that runs on PCs, the cheapest things out there. One version of Linux is Ubuntu. That's what Chesapeake has on it. Another version of Linux is Android. Android is a type of Linux. Nobody got any money for that. Okay? It wasn't like they paid the hackers who had created Linux for it so that they could put it on their Android device. Yep. Android is a type of Linux too. For that matter, if you're familiar with it, so is Google Chrome OS. How did this happen? I mean, you can't go to Microsoft and download Windows.C, the C program behind Windows. I mean, there's actually tens of thousands of Windows programs that make up Windows. You can't make changes to your Windows on your computer. You can't go in and like change the source code or something like that. And that's because Microsoft owns it. I mean, those little boxes that you clicked on when you installed Windows, or when you bought it from the computer store and booted it the first time, said things like, I will not be tampering with the source code. Okay? You're in violation of the original manufacturer's agreement or whatever if you do. But Unix isn't owned by anybody. It's a standard. It's not a product. And so anybody, within the terms of the GNU Standard License, which we can talk about some other time, can download it, modify it, use it, try to improve it, try to sell it, try to give it away, whatever they want. So if I want to download a copy of, let's say, Ubuntu Linux and make some changes to it, and I want to call it John OS, it is absolutely okay. And you know what? If I want to give John OS away, I can. If I want to charge people for John OS, if they're willing to give me money, I can charge for it. Okay? Whole different world with Unix. Okay? Ultimately, that's what Apple did, though, right? Apple ultimately just took a copy of Unix and started charging for it. Well, I mean, after they made changes to it and rebranded it as Mac OS X. That's what Google did with Android, right? Google went and downloaded a copy of Linux, made changes to it so it worked on these kinds of screens and this kind of chip, and called it Android. By the way, that's what Amazon did to Google. They took a copy of Android and modified it to make Fire OS, which is what runs on like Kindle Fire tablets and so on. That's just the way the nature of the GNU Standard License is, okay? I mean, as long as if you want to give it away, you can give it away. If you want to sell it, if somebody will pay you for it, great. In the real world of meteorology is all done on Linux. Now, at your job someday, you might be sitting in front of a Mac or sitting in front of a PC, but you're going to be, just like in this class, opening up a window that takes you to a Linux computer where you'll be doing modeling or producing graphics or editing video or controlling observing equipment or whatever. Meteorology is done on Linux, okay? You can be sitting in front of a Windows computer. I mean, I've got Chesapeake right here under my desk with its keyboard sitting here on the table, and I have to admit I usually am sitting like 2 feet farther over from there. Someday I'll show you my workspace. My laptop. And you know what I'm doing on my laptop? About half the time I'm logged into Chesapeake, which is like 2 feet away. Okay, why? Because I like being on my Windows 7 computer. I got my music playing over here, and I've got my Twitter feed over here, and over here in this other window, I'm logged into Chesapeake, and I'm doing work. Right? Okay, I'm really doing my work on Chesapeake though. The machine that I'm sitting in front of might be Windows, but the work is actually getting done on the Linux computer. And therefore, getting experience with working with the Linux operating system is an intrinsically good idea. Therefore, that's what we're doing this semester. So what's going to happen here is you're going to start moving on to these other next couple lectures that's going to show you how to get logged in to Chesapeake, whether you are sitting at a Mac or sitting at a PC. You'll have a couple of different options as to how to do it. And once you're in, you'll be doing things like resetting your password and starting to learn how to move files around and how to create files and how to edit files, and eventually how to do things like write your own graphic software that produces contour maps. It's going to be brilliant. But it's going to take us a while to get there. Along the way, we're going to have lots of fun with that really opinionated In the Beginning book by Neil Stephenson. I love the fact that book's like 20 years out of date. Because this gives us a chance to look back and see what did he have right and what things changed in ways he hadn't predicted, which is a fancy way of saying wrong. Okay, I hope that this gets us through that first slideshow, and please let me know if you have any questions. This has been Dr. John Schrage.